All right. Uh, in the last class, we talked about data communications, the meaning of data communication, which has to do with exchange of information between devices. And we talked about some characters of data communication, where we talked about delivery, accuracy, timeliness, and of course, jitter. And we explained all those characters in the last class. Jitter in the sense that the variation in the packet arrival time, especially when it has to do with videos and audios. So, excuse me, in summary of that class, we were concerned with the definition of uh, data communication, and we did justice to the characters of data communication. Today, we start from components. Excuse me. That is the other part. We are still on data communications, but we want to talk about components, the things that participate in data communication. What are those things? Let's start. We want to talk about components. So if data communication was to take place, what are the things that will partake? Those are the components. Now, a data communication system has 5 components. What are the 5 components that we have in data communication system? If 2 devices, like we made an example in the last class, using your phone, a data cable, and your system, trying to share a file, maybe a video or an audio file. If that process was to be completed, what are the things that will be needed? Those are the components that allows for the success of data communication. We have 5 of them, the likes of message, sender, receiver, the transmission medium, and the protocol. And we'll talk about the 5 of them in this class. The first thing that happens in data communication is that you must have a message. That is even to start with. Communication will take place because there is a message to pass from someone to someone, from a device to another device. So it has to start from a message. In the case of you trying to transfer a file from your computer to your phone using your USB cord, that file, the video that you want to transfer, represents the message. The message is the information or data to be communicated. Popular forms of information include text, numbers, pictures, audio, and video. All those are messages that can be shared, that can be communicated. So the message is that thing, that data, that information that you want to share between the 2 devices that want to communicate with each other. The other thing that is important is when I have a message, then there must be someone who wants to send the message. All we are talking about now is data communication components, the things that participate in data communication. If data communication was to be successful, what are the things that we need or that will participate in the process? The first one is the message. Of course, there must be something you want to pass, you want to share before communication can take place. That's the message. The other thing is the sender. There must be someone who wants to pass the message. In the case of your computer sharing a file to your phone, your computer becomes the sender. Now, the sender is the device that sends the data message. It can be a computer, a workstation, a telephone handset, a video camera, and so on. Apart from having a sender, and a message. It becomes communication because there is someone somewhere to receive that message from who is sending it. That is when communication takes place. So another device must be ready to receive the message being sent by the sender. So the next component of data communication is the receiver. We have 5 components. Don't forget the message, the sender, and now we're on the receiver. The receiver is that device that receives the message being sent by the sender. The receiver can also be the same thing with the sender. Like if a phone is sending something to another phone, the first phone sending becomes the sender, the one receiving becomes the receiver, but the communication is taking place between phones. So it can be the same device, but not one single device. We have like 2 or more in order to communicate. So after that, we have the transmission medium. That is the path through which the message you want to send will pass through. In the case of using a data cable to send a file, like a video file from your computer to your phone, that data, that your USB cord becomes the medium that the data will pass through from your computer to your phone. If you are using Bluetooth, Bluetooth becomes the medium. If you are using infrared, infrared becomes the medium. If you are using Wi-Fi, Wi-Fi becomes the medium. So that medium, that the message, the file or whatever you want to send will pass through from the sender to the receiver becomes the transmission medium. Very important because that is when messages can be communicated. Okay, so after that, we have the protocol. Now, what is the protocol? You may be very familiar with all other things like the message, the sender, and the receiver, and even the transmission medium. But it seems the protocol is somehow new or somehow such a big word now. So let's break it down. A protocol is a set of rules that govern data communications. It sends an agreement between the communicating devices. Without a protocol, devices may be connected but not communicating. Just as a person speaking French cannot be understood by a person who speaks only Japanese. Now, that's the protocol that we're talking about, just like a set of rules, an agreement, a kind of both the sender and the receiver being on the mutual ground that they understand each other. These are rules you have to follow. Okay, I will send you, you click on accept. It's because we know, because device A and device B, they are on the same ground, on the same level. They follow the same agreement, the same rules. Those are protocols. So for data communication to take place, we have 5 things that must be put in place. The message is important, the sender, the receiver, the transmission medium, and the protocol. Without all these, communication between devices will not take place. Now that will take us to data representation. Information today comes in different forms such as text, numbers, images, audio, and video. So data representation is the form in which your data, your message appears. And we have several ways a message can appear. It can be in form of text, which is a very popular one. What is written in this material is in form of text. You can have numbers, you can have images, you can have audio, and of course, video. So let's talk about each of them. When we say data in form of text, what do we mean? In data communications, text is represented as a bit pattern, a sequence of bits, eyes, different set of bit patterns have been designed to represent text symbols. Each is called a code, and the process of representing symbols is called coding. Okay. Today, prevalent coding system is called Unicode. The prevalent coding system, that means the most the most common, the most used coding system that we have today is a Unicode. It uses 32 bits to represent a symbol character, to represent a symbol character used in any language in the world. The American Standard Code for Information Interchange, that is ASCII. This is something you have been seeing before, but you might not know the full meaning. The American Standard Code for Information Interchange, the ASCII. Now, developed some decades ago in the United States, constitute the first 127 characters in Unicode and is also referred to as the Basic Latin. There is this there is this symbol, that kind of image that contains these 127 characters. I don't know, we'll meet this, I would have get it prepared so that will show us in this class. So that is for text. The major thing we should pick on that text is that they are represented using bits. And for Unicode, it's represented using 32 bits. Then we have the American Standard Code for Information Interchange that developed the 127 characters in Unicode. The one form of representing data is representing them through text. And in data communications, text is represented as a bit pattern, a sequence of I. In the Unicode uses 32 bits to represent data in form of text. So if you are asked, the ASII developed developed a Unicode standard system with how many characters? 127 characters. So that is for text. Don't forget. And the 127 characters in Unicode developed by the ASCII is called the Basic Latin. Basic Latin. Now, numbers. That is another way of representing data. Don't forget what we are doing right now is talking about data representations. We have several ways like text, numbers, audios, videos. So we have talked about text. Now we are going to numbers in regards to representing data. Numbers are also represented by bit patterns, just like the text are represented by bit patterns. However, a code such as ASCII, that is American Standard Code for Information Interchange, is not to represent numbers. The number is directly converted to a binary code to simple mathematical operations. That is binary code in sense of zeros and one. So for number, they are also represented by bit pattern, but the ASCII cannot represent number. We don't use it to represent number because numbers are converted directly to binary codes. That is how to represent numbers in data representation. Convert them directly to binary codes and simple mathematical operations. Then we have the images. We know that several ways images are represented because we work with pictures so much in this generation. Now, images are also represented by bit patterns. In the simplest form, an image is compound of a matrix of pixels, picture element. Pixels are picture element. You see, an example of pixel is, you see all those old television, black and white. You see those dot that used to appear on it if it's trying to look for signal. That is an example of pixels. Those are the things that will later form the image that is to be projected. So, compound of a matrix of pixels, picture element, where each pixel is a small dot, you see? That is what I've tried to explain using that television, that old box TV. The dot you are seeing, they are pixels. They are the ones that will connect together and form images on the television screen. So the size of pixel depends on the resolution. For example, an image can be divided into 1000 pi or 10,000 pixels. In the second case, there is a better representation of the image based on resolution, but more memory is needed to store the image. Of course, you know that the higher the resolution of an image, the more memory you will need. For instance, if you snap an image with an iPhone, it might be as high as 100 MB. If you snap with just an ordinary Android, maybe just be having like 10 MB because of higher resolution on iPhone. So that's why you see that of iPhone will consume more memory on the phone memory than that of Android because the resolution is not that high like that of the iPhone. Now, what I'm just trying to tell you here is that pictures also come in bit patterns, but they are formed through pixels, and pixels means picture element. So, and then the size of the pixel depends on the resolution. So the higher the resolution, the more memory the picture will consume. That is the summary of that place. Now, after an image is divided into pixels, each pixel is assigned a bit pattern. The value of the pattern depends on the image. For an image made of only black and white dots, e.g., a chessboard, a 1-bit pattern is enough to represent a pixel when there are not so much color or colors on the image. That is what they're trying to say here. So the closer to black and white the image is, the lesser the value of pixels that are needed to form it. Now, if an image is not made of pure white and pure black pixels, you can increase size of the bit pattern to include grayscale. For example, to show 4 levels of G scale, you can use 2-bit patterns. A black pixel can be represented by 00, a dark G pixel by 01, a light gray pixel by 10, and a white pixel by 1, 1. Now, what they are trying to say here is the images to be formed, the resources you will need to form them will be dependent on how far the image is from black and white. I don't know if you have gone to all those printing shops and the rest of them, where you see large printers. When they want to print something, if that thing is in black and white, the money will be cheaper. But the more color variations you have on that image, the higher they will charge you, because each color appearing on the image is going to add more value to the pixel, and to form higher resolutions, that's higher content. Now, they are giving us an example here of some G scales that we can use for image formation using pixels. You can form a 2-bit pattern. Like, for instance, a black pixel can be represented by 00 on the G scale. A dark G pixel is 01, a light gray pixel is represented by 10, and a white pixel is represented by 11. That is on black and white pictures or images. Now, there are several methods to represent color images. To move to color images now, this one is for black and white. To move to color images now, we say there are several methods of representing color images. One method is called RGB, so called because each color is made of a combination of 3 primary colors: red, green, and blue. That is the full meaning of RGB. You used to see this RGB very well, especially when you want to edit pictures, whether on Photoshop or even on your phone. You see the RGB. They will say add more RGB. That is color mixture of red, green, and blue. Now, the intensity of each color is measured, and a bit pattern is assigned to it. Another method is called YCM, in which a color is made of a combination of the other primary colors: yellow, cyan, and magenta. Those are colors. The primary colors. Now, the yellow is a mixture of 2 primary colors. The cyan is a mixture of two primary colors. Even the magenta is a mixture of two primary colors. So that is the other way in which color images are formed. The two ways color images are formed are the RGB, the red, green, blue pattern, and the YCM pattern, yellow, cyan, and magenta pattern. For the black and white, it can come on scales. We use the G scale to measure it. It can be the dark, which is 0, 0, sorry, the black 0, 0, the dark 0, 1, the light gray 1, 0, and the white pixel, which is 1, 1. So, having done this, we've talked about images, data representation in form of images, and the different patterns we have. You know, images come in black and white and in color. That is the two basic you should know. Images can come in black and white and they can come in color.